Hello, sir. Myself, Nabanita Barai from Electronics and Communication Engineering Department, second year. My roll number is 349003233029. The subject is Analog Communication, EC 401. And my today's topic is modulation and its types. So, in the contents, we have Introduction to Modulation, Types of Modulation, Analog Modulation, Digital Modulation, Comparison of Modulation Technique, Applications of Modulation, and Conclusion. In next slide, we have Introduction to Modulation. Definition of modulation. Modulation is the process of varying a carrier signal's properties, such as amplitude, frequency, or phase, to encode information for transmission over a communication channel. It helps in transmitting signals over long distance, reducing noise and interference, efficient utilization of bandwidth. Next, we have types of modulation. First, analog modulation. Second, digital modulation. And in the right side, there is a diagram. First, analog modulation. There is three types of analog modulation. Number one, amplitude modulation, AM. Amplitude modulation, AM, is a type of analog modulation in which the amplitude of the carrier wave is varied in proportion to the instantaneous amplitude of the message signal while keeping the frequency and phase constant. Its applications: radio broadcasting, AM radio, aviation communication. Number 2, frequency modulation, FM. Frequency modulation, FM, is a type of analog modulation in which the frequency of the carrier wave is varied in proportion to the instantaneous amplitude of the message signal while the amplitude remains constant. Its applications: FM radio, TV sound broadcasting. Number 3, phase modulation, PM. Phase modulation, PM, is a type of analog modulation in which the phase of the carrier wave is varied in proportion to the instantaneous amplitude of the message signal while keeping the frequency and amplitude constant. Its application: used in wireless and satellite communications. Second, digital modulation. There is also four types of digital modulation. Number 1, amplitude shift keying, ASK. Amplitude shift keying, ASK, is a digital modulation technique in which the modulation of the carrier signal is varied in response to digital data while the frequency and phase remain constant. Number 2, frequency shift keying, FSK. Frequency shift keying, FSK, is a digital modulation technique in which the frequency of the carrier signal is varied according to the digital data being transmitted while the amplitude of phase remain constant. Number 3, phase shift keying, PSK. Phase shift keying, PSK, is a digital modulation technique in which the phase of the carrier signal is varied in response to the digital data being transmitted while the amplitude and frequency remain constant. And number 4, quadrilateral amplitude modulation, QAM. Quadrature amplitude modulation QAM is a digital and analog modulation technique that combines both amplitude shift keying ASK and phase shift keying PSK to encode data into a carrier signal by varying its amplitude and phase. Now let's see the comparison of modulation technique. In amplitude modulation AM, bandwidth requirement is high, noise immunity is low. It's used in radio broadcasting, aviation communication. In frequency modulation FM, bandwidth requirement is higher than AM, noise immunity is high. It used in FM radio, television audio, two-way radio. In phase modulation PM, bandwidth requirement is similar to FM, noise immunity is high. It used in digital communications radar systems. In amplitude shift keying ASK, bandwidth requirement and noise immunity is low. It used in optical fiber communication, RFID, low speed data transmission. In frequency shift keying FSK, bandwidth requirement is moderate, noise immunity is moderate to high. It used in wireless communication, Bluetooth, RFID. In phase shift keying PSK, bandwidth requirement is moderate, noise immunity is high, and it used in satellite communication, Wi-Fi, cellular networks. And quadrature amplitude modulation QAM, bandwidth requirement is high, noise immunity is moderate to high, and it used in high speed broadband, cable TV, 4G and 5G networks. Now there are some applications of modulation: radio and TV broadcasting, mobile communications, satellite communications, data transmission, Wi-Fi, IoT. And right side there is two diagram. For the last slide we have conclusion. Modulation plays a crucial role in communication systems by allowing signals to be efficiently transmitted over long distance while minimizing noise and interference. There are two main categories. First, analog modulation, and second, digital modulation. First, analog modulation, AM, FM, PM, used in radio, TV and traditional broadcasting. And second, digital modulation, ASK, FSK, PSK, QAM, used in modern communication like Wi-Fi, mobile networks and satellite communication. Each modulation technique has its own advantages and is chosen based on factors like bandwidth efficiency, noise immunity, and application requirements. With the evolution of technology, advantages modulation systems like QAM and OFDM continue to enhance data transmission in high-speed networks. Thank you. That's all about my today's presentation.